Alright, what we have here is a quadratic equation. Y equals ax squared plus bx plus c. Okay? The difference so far between this and the linear equations is this ax squared piece, right? If we look at this bx plus c, it's kind of like mx plus b. Same thing. Okay, so a quadratic equation looks a little bit different though. It's not a straight line. It looks like a horseshoe. Okay, we call this horseshoe a parabola, right? Or a parabola, depending on who you talk to. Now, parabola has two different directions it can point. It can point up like this, okay, or it can point down like this. What determines whether it points up or whether it points down is A. A is the coefficient in front of the term with the square in it. Okay, so if A is a positive, it points up. If A is a negative, it points down. Okay, so if we have the equation y equals negative 2x squared plus 4x plus 7, okay, that's going to point down because our a value here is a negative. Now if we have y equals negative 3x plus 4x squared plus 6, which way do you think that one's going to point? Okay. Well, some of you might look and say, well, the a value is negative. Now, the a value is not the first value here. It's the value, it's the coefficient in front of the x squared. Okay? So it's a 4. So this one's a positive, so it points up. Alright, now there's some interesting things with a parabola. Okay? One is the y-intercept. Okay? And just like when we're dealing with a straight line, the y-intercept occurs, okay, at that value right there. That c, that's the y-intercept. Right? So the y-intercept would be 0, comma, c. Okay? Because when x is a 0, we're on the y-axis. When x is a 0, what term are we left with? We're left only with the c. Okay? Now the parabola also has this thing called a vertex. The vertex is, well, I like to look at the vertex. It's the starting point of your parabola. Okay? The vertex is where that parabola begins. If you have a positive parabola, in other words, our a value is positive and it's pointing up, our vertex is a minimum. Okay? The reason it's a minimum is because our parabola is never going to be smaller than this point right here. It will never be smaller than the minimum. Okay? So if our vertex is a negative 3, we can never have a y value below the negative 3. Okay? Now if we're talking about a parabola that has an a value that's negative, in other words it's pointing down, the vertex turns into a maximum. Because that becomes the maximum height you will ever reach according to the y-axis. Okay? So you can never be taller than that vertex of a maximum. Okay? The vertex also ends up being this point of symmetry, to where if I were to draw a straight line that included the vertex, okay, and was parallel to the y-axis, I could take a piece of paper and fold the two sides of the parabola on top of each other, and they would line up perfectly. Okay. The other thing a parabola can have is it can have x-intercepts. It's possible that a parabola, though, could have 2 x-intercepts. So this is different than before. With a straight line, we only ever had 1 x-intercept. But with a parabola, we could have 2 x-intercepts. Okay? It's also possible with a parabola, look at this parabola right here, okay, that you could have 0 x-intercepts. It's also possible maybe you could have a parabola that looked like, a decent pin here, oops, not quite a parabola that looked like that, where the vertex started on the x-axis. Well, in that case, you only have 1 x-intercept. Here you've got 2, okay, 0. So it's possible you could have 2 x-intercepts, 1 x-intercept, or 0 x-intercepts.